So 2 degree of freedom vibratory system is shown, and we have to determine the natural frequency of vibration and the ratio of amplitude of both the masses m1 and m2. And the given conditions are the masses of the system is given as 3 kilogram and 2 kilogram, and spring constant k1 and k2 is also given as 30 newton per meter and 15 newton per meter. We have to determine the natural frequency of vibration and the ratio of amplitude. So let's look at the step by step method to solve it. So this is a given figure. We have a spring, two spring of mass m1 and m2. So spring and mass system is given, and these are the given conditions. M1 was 2 kilogram, sorry 3 kilogram, and m2 was 2 kilogram, and k1 and k2 the spring constant are 30 newton per meter and 15 newton per meter. So first step is to draw the free body diagram of both the mass system. So if we take m1, you can see the top part of this spring is fixed. So basically, when a displacement act downwards, that x1 is the displacement of the mass m1 and x2 is the displacement of mass m2. So when there is a displacement of mass m1, obviously this will elongate. Okay, a spring force will be developed inside the spring due to the x1 displacement, and that will be opposite to the direction of motion. Here the direction of motion of this mass m1 is downward, and the spring force developed is opposite to the motion. Why? Because it is fixed here. Since it is fixed and the motion is downward direction, so the displacement, the spring energy due to the displacement x1 will be in the upward direction. That is shown k1 x1 in the upward direction, and obviously they will be having some acceleration. Here x1 is shown as the displacement, x1 dot is represented velocity, and x1 double dot is represented acceleration. That's the normal convention or way in which acceleration and velocity are represented in a vibration system. So same way I will be using it here. So m1, this is it's simply m1a. Okay, m1a1 ma. Okay, that the force developed due to the acceleration is ma. So here it is written as m1 x1 double dot. Okay, the same thing. It simply means ma. Okay, and if you look at the downward portion, and the spring is attached to the mass m1 k2, but this whole thing is a system, right? So m1 will be having a displacement x1, m2 is having a displacement x2, and this k2 is in middle of this both masses m1 and m2. So obviously the net displacement is cannot be expressed in terms of a single entity, either x1 or x2. It has to be the difference in displacement of both the masses. So x2 minus x1. So m1 is having a displacement of x1, m2 is having a displacement of x2. So if both masses when it go downward, there will be a difference x2 minus x1. That small difference is what caused the spring energy in k2 with respect to m1. Since it is not fixed, it is a moving mass along with uh, m2 with respect to m1, so that will not be in opposite direction of motion, it will be along the direction of motion. That's why k2 into x2 minus x1 is in the downward direction, because it is not fixed and another mass m2 is moving downward along with the k2. So the spring energy due to k2 with respect to m1, that will be downward direction, not upward direction. That means opposite to motion. So this is the free body diagram of both of mass m1 system. We took the m2. M2 is having only one spring. Okay, it is also having a displacement x in the downward direction independently. So obviously, MA acceleration will be into x2 double dot. Okay, MA acceleration just like mass of m1, and only one spring is attached. And here, if you look the spring force of m2, it will be in the opposite direction of motion. Why? Because this spring it seems like attached. It is not move attached to this point with respect to m2, just like k1 with m1. So same way, the spring force in this point will be in the opposite direction of motion. Okay, there will not be any net displacement like x2 minus x1. If you take m2, the only spring will be considering is k2, and k2 act like m1 is fixed. So it is like a fixed body, So that we won't be considering any displacement of x1 or m1 when we consider m2 alone. So considering it as a fixed mass, we'll be getting this k2 and x2 minus s1 will be in the opposite direction of this motion. Okay. So this with respect to m1, it will be in the same direction of motion. When considering m2, it will be k2 into x2 minus x1 will be in the opposite direction of motion. So we have a free body diagram of both the body. So the last step is considering Newton's second law of motion. So Newton's second law of motion is used to uh, solve this type of problem. So we know what is Newton's second law of motion, that the net force is equal to ma. Okay, here in the case of A, we will be representing x double dot. I already explained. So net force is equal to ma, net force. So if we consider mass m1, the net force can be these are the net force and this is ma. So m will be m1 because we're considering mass m1. So m1 into x double dot. Well, net force k1 x1 is will be negative because in the upward direction, and k2 and x2 minus x1 is downward, so it is positive. So net force will be minus k1 x1 plus k2 into x2 minus x1. So if I rewrite, it will be eventually this equation k1 m1 x1 double dot plus k1 plus k2 x1 equal to k2 x2. So I'll be naming it as equation number 1. Similarly, we can do mass m2. The net force is only minus k2 into x2 minus x1. Since that force is in upward direction, will be given negative. That's why minus k2 and equal to ma, where mass is 2 m2, so m2 x2 double dot. So we get the two equation by applying Newton's second law of motion to the two mass system m1 and m2. So when we do solve this type of vibration problem, there are certain assumptions that will be taken. So here we are, I already told there will be x1 displacement for mass m1 and x2 displacement mass m2, and that displacement will not be in a uniform manner. It will be considered as an harmonic motion. That's the basic assumption we'll be taking in a vibration problem. So you just have to keep that in mind. That will be the procedure when doing this type of problem, because the force applied won't be in a uniform or in a constant repetition. It will be in harmonic motion. So usually the displacement due to the force will be also in harmonic motion. So x1 and x2 are the respective displacement of both the body m1 and m2. So the displacement can be explained in terms of harmonic motion as capital X1 sin omega t and capital X2 sin omega t. Okay, so you don't need to worry about it. Just learn it that way. Capital X1 and capital X2 are the amplitude of the respective displacement. So displacement along is a harmonic motion, so obviously there will be amplitude for a harmonic motion, that would be capital X1 for X1 and capital X2 for X2. And omega is sin omega t, that phase angle is same for both the motion. That is also one assumption. The displacement, the phase angle of the displacement of both the mass is also same. So that's why it's omega t, the phase angle part is same for both the equation. Okay, this is the equation we have to consider. So next step is uh, we already got two equation, 1 and 2. So there are expression for x1 double dot and x2 double dot. So what you have to do is we find x1 double dot and x2 double dot from this equation and substitute in our original equation. The first equation we already derived. So x1 x1 single dot means you are taking single derivative. This will be the velocity. Double dot is acceleration. So we have two uh, we got x1 double dot and x2 double dot. So next step is simple substitution to the first equation. So when these are the steps of substituting to the first equation. I mean the mass 1 m1. Okay. So substituting to mass m1. So this will be the equation after substitution. And in this question we have certain parameter. M1 is 3 kilogram, M2 is 2 kilogram, K1, K2. So we have to substitute that. Okay, we have asked to substitute that because it is given in the question. So substituting that given value, eventually we get like this simple steps. Okay, the simple substitution and the many term will be get cancelled. So sin omega t same on both sides. So that will be get cancelled. and we have to find x1 by x2. X1 is the displacement, I mean amplitude. Okay, sorry, it's not displacement. Capital X1 by capital X2 means the amplitude ratio of both the masses. Okay, so when substituting the first equation, I got this equation as 15 by 45 minus 3 omega square. After substituting the given value in the question, we'll be getting the amplitude ratio of the first equation of first body will be this one. So same way we can do second body. Same way substituting the second equation for mass m corresponding x2 double dot, if you substitute and simplify taking common, same ratio x1 by x2, the ratio of the amplitude can be found out by the second equation, which is 15 minus 2 omega square by 15. So we got the two equation for the amplitude ratio x1 by x2. So since the LHS of both the amplitude ratio is same, I will be equating the right hand side. Okay, so the right hand side, when equating right hand side, we'll be getting this equation. Obviously, we'll be getting this equation as 6 omega raised to 4 minus 135 omega square plus 450 equal to 0. So this is not in the form of quadratic equation. I cannot solve in this manner. So there is simple trick we will be doing not to solve it in quadratic equation. That is just giving a substitution that omega square is equal to alpha. Just assuming that omega square is equal to alpha, we get same way substituting the second equation for mass m corresponding x2 double dot, if you substitute and simplify taking common, same ratio x1 by x2, the ratio of the amplitude can be found out by the second equation, which is 15 minus 2 omega square by 15. So we got the two equation for the amplitude ratio x1 by x2. So since the LHS of both the amplitude ratio is same, I will be equating the right hand side. Okay, so the right hand side, when equating right hand side, we'll be getting this equation. Obviously, we'll be getting this equation as 6 omega raised to 4 minus 135 omega square plus 450 equal to 0. So this is not in the form of quadratic equation. I cannot solve in this manner. So there is simple trick we will be doing not to solve it in quadratic equation. That is just giving a substitution that omega square is equal to alpha. Just assuming that omega square is equal to alpha, we get we get it can be rewritten as 6 alpha square minus 135 alpha plus 450 equal to 0. It's a simple trick not to get this solved by using quadratic equation. So the corresponding now this is in the form of quadratic equation. Obviously there will be two solution or root lambda 1 and lambda 2. So this is not the actual solution because we are given the substitution omega square is equal to alpha. We got two solution as alpha 1 and alpha 2. So in order to find the first omega is the natural frequency. In order to find the two alternate solution of the first natural frequency, just take taking this way, okay, omega n1 square equal lambda 1 and omega n2 square is equal lambda 2. Right, there will be two solution. Obviously, there will be two solutions. So this is the natural frequency of the first case, and this is the natural frequency of the body. I mean second body. So we have got the frequency. We've already got the amplitude ratio. That's what they're asking the question, amplitude ratio. And now we got the frequencies of both the body. Okay, this is how to solve this problem. So the solution of this question actually ends right there. But I'm explaining additional one more topic. Some question they may ask along with this to find the mode shape. Okay, they might ask amplitude ratio to find the natural frequency that I already explained. So some question they already they may ask to find the mode shape also. So what is mode shape? So these are the two nodes, and this is what they mean. We have to find the nature of these modes. How did it look like? So how do you find? We have corresponding omega n1 square and omega n2 square by solving that equation. So the reason why I take square is because the ratio we need to substitute that in the equation of the amplitude ratio. There it is an omega square. So I only need the omega square term. Okay, that's why. So there are two nodes for like we already got taken the first mass equation. We got the amplitude ratio as the first mode. due to the first natural frequency, and these two modes will be obtained by having two natural frequency. So the first natural frequency, that's omega n1, will be having one mode, and omega 2, second natural frequency, will be having a second mode. So how do you find these two modes? To get the first mode shape, we have the first equation, amplitude ratio, considering the first mass system. That will be x1 by x2. We got substituting this equation. We now know the value of omega n1 square. It is actually omega square, right? The previous derivation it is omega square, but to get the first mode, we'll be substituting it as omega n1. I mean, taking the first mode means first natural frequency. So that omega should be omega n1 square. So I already know the value is 18.43. So when you substitute, it will be minus 1.45. That means x1 is minus 1.45 x2. Similarly, to find second mode shape, you need to take in the amplitude ratio obtained by considering the second mass system. So there also we get one equation as x1 is equal to 0.458 x2. So we got the relation between x1 and x2 for the two mode. How to find the shape of the mode? Shape of the mode means you need to find like nature of the graph, or the way in which the shape look like. In order to do that, just was follow one step. And first equation we have x1 is equal to minus 1.45 x2, right? So what I have to do is just assume x1 as 1. So if I substitute x1 as 1, x2 will be minus 0.689. So all I have to do is just draw a vertical line. This is not there is not any fixed distance. So it's a simple rough drawing only to depict the shape of the graph. I mean mode shape. So x1, if it are considering x direction as amplitude and this y direction as displacement. So this small x1 is actually capital X1, right? So capital X1 is 1. So this is the first point. I'm taking this point. Capital X1 is 1. Then after some distance, that x2 will be minus 0.68 in opposite direction. So then, okay, this is the way to draw more shape. Then simply just join these points. Okay, from here to here, then here to here. This is how to draw the mode shape. You can write by any value, not just x1 equal to 1. You can substitute any value. So based on that, this value will change. This is simple value, right? If you put x1 equal to 1, you get a simple numerical value, and simply you can show how does it look like. Same way to find second mode, we have the second equation x1 equal to 0.458 x2, right? In same manner, just substitute x1 equal to 1, we got x2 as 2.18. So if substitute x1 equal to 1, this x2 will be 2 point, that will be double the value, right? It will be obviously will be more than this. Then all I have to do is just join this arrow point. This is the way to draw the mode shape. Okay, thank you.